This first chapter in our course on statistics will be an introductory chapter. I will talk about what data science is as a field, what role it plays within a larger business context, and where statistics comes into play. Now, this will not be a technical chapter, so you can just sit back and enjoy this short introduction. And let's dive into the slides and start with the basics. So what is data science as a field? Well, it lies at the intersection between abstract mathematics on the one hand and solving real-world problems at the other hand. In a sense, you don't have to develop any new mathematics, but you do need to have a firm and deep understanding of the basics so that you can apply them to your own data set and thereby solve the problem that you are posed. So what exactly do we data scientists do? What is our project? Well, the main objective of a data scientist is to transform data into insights on which executive actions can be taken. Now, where does this data come from? Well, there are a different kind of sources. You have external data, for example, customer data. Let's say that you have a product or service which already has a large customer base. Now you want to roll out a new feature in your product, but you are uncertain whether people will actually like it or not. And this uncertainty makes it that it would be a foolish idea to just roll out this feature to all the customers, because then you might make the product worse and you might lose some customers. So what do? You roll out the feature to just a subset of customers, and then you gather this customer data and compare it with the data from customers that didn't have the rollout of this feature. Then you compare the data and you can see whether the customers indeed like it or not. Now, this is of course A/B testing, and we will dive into great detail on how to apply it using Python for your own data set. Another data source could be internal data. For instance, business intelligence data. How is the business doing as a whole? Can we gather data from this? Or for instance, supply chain data. Is there a supply chain that forms the bottleneck, or where in the supply chain is a bottleneck? In general, these questions boil down to just making better decisions. We want to transform the data such that business leaders can make better decisions. But what exactly does this mean, better decisions? Well, in my experience, the higher up the hierarchy you go, even all the way up to executive level, the more decisions are based around feelings and hunches, which themselves then are based on experiences. Now, these people are of course experienced, and therefore these hunches and feelings might very well be, in most of the cases, in the right direction. However, we can do better. What we want to do is to augment these hunches and feelings with numbers and figures. And in this way, a business leader can make even better decisions. And this gives us the data-driven decision. That's where we want to go to. That's our goal of the data scientist. Now you might ask, why is a data-driven decision better than deciding on experience or feelings? Well, just realize that a business operates in the real world. And what reflects this real world and the customer's decisions is customer data, or data in general. Therefore, a decision based on this data, which reflects the real world, will always outcompete a decision based on experience, because market dynamics might change, or based on feelings, because they might also change from day to day. So a data-driven decision is what we want. And to do this, we look at a concept called the data pipeline or the data chain. This is a bit of a simplified version right here, but it gets across the message. If we want to go from raw data all the way to actionable insights, we have to go through different types of steps that transform the data along the way. The first step, which goes from raw data here on the left-hand side, is data engineering. Now, data engineering is basically gathering all of the raw data, which can come from various different sources, and this data can be in various different types or forms, and bringing it all together in one database, and preferably within the same type of data, for the data scientist to access it. And then the first step of the data scientist is the data cleaning process. Now, the data cleaning process is basically looking at the data, identifying outliers, or looking at values that are invalid, and then handling them. Now, after data cleaning comes data modeling, and this is oftentimes seen as the most interesting or challenging part of a data scientist's role. Now, data modeling is basically starting from the entire data set and trying to transform it such that you get out what you want. Now, this could be a prediction using a machine learning model, or it could be implementing an algorithm that gets out what you want, but it doesn't have to be all that complex. It could be a simple aggregation function, for instance, taking the mean or looking at the distribution of your data. Then after the modeling is done, you get to the data insights abstraction. So you get out the subset of data that you want, a prediction or a mean or distribution, and you want to abstract insights from it that you can communicate to higher executives. Basically, what you're trying to do here is not lose sight of the goal. You are solving a business problem, and therefore you want to get a solution within a business context. Then after you have abstracted these insights, you make a presentation and you communicate clearly to higher executives what the conclusions of the data are. So let's now talk about statistics and where it comes into play. If you have this simple linear data pipeline, where do you think statistics comes into play? I will give you a few seconds to think about it. If you thought insights abstraction, then you are completely correct. Before we learn about what the role exactly is of statistics in insights abstraction, let's take a step back and think about what statistics is. Statistics uses established mathematics on data such that you can make conclusions with, and now comes the important part, with quantifiable accuracy. Now let's take an example, which we will come back to in great detail in later chapters. Let's say that you are given a data set, which represents a subset of data of the entire population. For instance, a subset of customers. Now, from this data, you're asked to compute the average purchase price of a customer of the entire data set. Therefore, you can compute the average purchase price for your subset, but then you want to extrapolate this to the entire population. Now, importantly, you cannot just take the average that you computed for a subset of data and say that it is the average for the entire population, because you might just be lucky or unlucky and have gotten a non-representative subset of customers. Let's say that in your subset, for some reason or another, you have customers that purchase a lot more than the general population. Therefore, your average extrapolated to the general population will be wrong, and therefore wrong business decisions will be made. And this is exactly where statistics comes into play. It allows you to generalize your findings on a subset to the larger population in a quantifiable manner. So you can, for instance, say that the average of the larger population is X or Y, and you can also give your confidence interval. And this is why statistics is such a fundamental and important part in the entire data pipeline. Even if you got a perfectly data engineered data set from the data engineers, you clean it very well, and you build a model that really works with high accuracy. If you then just make the wrong conclusions on the output and you communicate these wrong insights to the business executives, then you did not do your job as a data scientist well. Additionally, the role of statistics is not isolated to this one block, the insights abstraction. Instead, in all of the different parts in the data pipeline, a basic notion of statistics makes you much more effective and decreases the chance of making errors. Another reason why statistics is not isolated to this just one block in the pipeline is because this pipeline is an oversimplification. In real-world problems, you don't go through the pipeline once and then your job is done. Instead, at each point in the data, at each link in the chain, you might observe some behavior or something in the data which forces you to go back and redo some of the previous steps. For instance, you might see from your insights abstraction that you didn't do enough cleaning of the data. Outliers, for instance, play much a bigger role than you would like. Or you are modeling the data and you see that something went wrong with the data engineering. And that's why the statistics that you do in your insights abstraction trickles down to every other step in the pipeline. And this in turn means that a solid understanding and mastery of statistics means that you are a much better and effective data scientist. And this is important because we as data scientists have a large responsibility, because executive leaders depend and count on us. They depend on us because we provide them the insights from the data that their business is generating. And they want to be sure that what we provide them really reflects the underlying data and thus their business. Now, naturally, this puts the data scientist at a very central role within the organization, but of course with a lot of responsibility. And this responsibility you can only take confidently if you know your statistics are sound. And that is of course what we will learn in the following chapters.